Okay, so today we will going to start the second section, that is pre-stressed concrete, new topic. Okay, in the first section now, that retaining wall and water tank we will take at the end. Okay, so that design is very lengthy and very cumbersome, so we will take that design at the end. With the permission of sir, I have talked with the sir regarding this. Now we will switch on to the second section, as we have completed 2 units in the first section out of 4 units, and in second section 5 units are there, out of which the today's unit is a very short unit, that prestressed concrete. Okay, it will end up within 1 hour and so. And if it is end up within this 2 hours time duration, then we will move on to the next unit after taking the MCQs. Okay, so for now, what we are taking that from the second section, we are taking the unit number 5, Introduction to Prestressed Concrete Concepts and Methods of Prestressing. That we will see. So I have made the PowerPoint presentation for that. So from that we will do it. Continue. Wait, just wait. I will share the screen with you. Screen is visible to you? Will you please give me the reply? Screen is visible to you? Anybody can tell me? Is it visible? Shraddha, Harshad, Shraddha Survase, Shraddha Chavan. Anybody can give me the reply. Is this the screen is visible or what?
Yes, sir, visible.
Okay. Okay. So now we will start with this prestressed concrete. Now prestress means what? Yeah. So prestress means what? Generally, what is our normal concrete is now. If I draw the diagram over here, okay. So if you see our normal concrete, and then I will draw the beam. Suppose now this is a beam. Okay. So in this beam, we place the steel reinforcement. Normally, we design the steel reinforcement for the bottom. Here, the steel reinforcement is there. On the top, also we provide the steel reinforcement, but that is for earthquake. Okay, here at the top. So normally, in the case of beams, what we do, we design it for the this steel, whatever we have provided here. Okay. This steel at bottom in the beam. This steel. This is to resist the tension. This is to resist the tension, and this we design by calculating the bending moment. We calculate the bending moment at the bottom, and the steel which is provided at the top. Okay, so this steel which is provided at the top. This is generally provided minimum 2 bars of 10 mm diameter are provided at the top. This is minimum I am talking about. This is according to the IS code. Okay, IS code suggests that even though if there is a very less amount of bending moment at the compression side of the beam, still you need to provide the minimum 2 bars of 10 mm diameter. So generally we don't design the bars which are provided at the top of the beam. Okay, at the top of the beam. And generally we design the bars which are provided at the bottom of beam. Same if I show you the cross section. Here if you see the cross section of this, see this is the cross section. Here you can say that these these are the bars. These are the bars which are at the bottom. It will look like this. Okay, these are the bars which are provided at the bottom. Okay, these are the bars which are provided at the bottom. And if you see the bars which are provided, which are these top bars, these are the top bars which are provided to resist the earthquake. By keeping in mind of the earthquake forces, sometimes the reversal may happen. Okay, whenever the structure is subjected to earthquake forces. Okay, so to resist that up to the some extent, we provide these bars. So these bars are not designed. These bars are not designed. Okay, remember this. These bars are provided as per the norms, and these bottom bars are designed for the bending moment. And what we generally do, we provide the stirrups around this. Okay, the stirrup is provided to resist the shear. The stirrup is provided to resist the shear. These are the stirrups. Okay, these are the stirrups. Okay, this I have talked about the normal beam. Now in a prestressed concrete member, same thing is happen. Okay, in the prestressed concrete member also the same thing is happen. If you consider the prestressed beam, the design is same, but the only thing is that what we do, if you see this steel bar in I'm talking about prestressed concrete. This is in a normal beam. In the prestressed concrete beam also the same thing is there, but the difference is that this is the bar which is at the bottom. Okay, this bar, it is given, it is on that bar we apply some forces. Okay, we apply some compressive forces, so due to which what happened, the stresses, internal stresses are getting developed in this bar. Internal stresses will getting developed in this bar, and those stresses resist the stresses which are developed due to the loading. Those stresses resist the stresses which are developed due to loading. Okay, are you getting this point? Are you getting this point? If you read this, same thing is over here. A prestressed concrete member is a member of a concrete in which internal stresses are introduced in a planned manner. Okay, so we introduce their internal stresses. Okay, introduce, the word used here is introduce, means purposefully we introduce the stresses. Okay, see, understand this. A prestressed concrete member is a member of a concrete in which internal stresses are introduced. So we introduce the stresses in a planned manner. So we introduced it in a planned manner. So some calculations are there that we will see in the units which coming later on in unit number 6, 7. We are going to see this. Okay, so plan manner, so that the stresses resulting from the loads are counteracted to desired degree. So why we do this? We do this because we want to counteract the stresses which are developed due to the loading which is acting on the beam. Okay, so if you see this is the beam, then the loading will act on the beam. Sulfate is the UDL, then somewhere point load may be there or any other type of load may be there. Due to this loading, okay, there will be the generation of bending moment. Also, there will be the generation of direct stress as well as bending stress. Okay, in while teaching the DCS2, I have told you what is the direct stress, what is the bending stress. While we learn the design of column in that. Okay, so similarly here also due to this loading, direct stress as well as bending stress is getting introduced over here. Okay, and to counteract these stresses, we do this thing. Okay, now how it is going to be done? ते कसं करायचं, how it is going to be done, that we will see later on. How it is to be done and how it is to be achieved. मग त्याला स्ट्रेस कसा दिला जातो, कसं इंट्रोड्यूस केलं जातं, that we will see later on. Okay, first the thing is that you should understood the concept that whatever, suppose now here you can see on the screen the beam, the tendon which I have shown in the red color. Okay, this is our design. Tendon means bar, the reinforcement. Okay, ज्याला आपण स्टील बार म्हणतो, स्टील बार इट इज कॉल्ड ॲज अ टेंडन. नॉर्मली द वर्ड यूज ॲज अ टेंडन इन प्रिस्ट्रेस कॉन्क्रीटिंग. Okay, I will write here tendon. This word is used for the steel. Okay, tendon. Okay, so this bar, what we will do, we will apply some forces on this bar so that the internal stresses will get developed in the bar, and we apply the force in such a planned manner so that the internal stresses which are getting developed in this bar, those stresses are in the opposite direction to the stresses which are developed due to loading. In the sense, opposite direction means stress. We do not specify the stress by direction, but just we can see that this load is vertically downward. So normally the stress induced is that at the bottom tensile stress is there, at top compressive stress is there. Okay. So to counteract those stresses, we apply the forces on this tendon so that this stresses level or this stress level comes to it tries to neutralize that. Okay. Now, how it is achieved? So, have you understood this point? Whatever I have told you, have you understood this? Anybody? If not, then I will repeat it once again. Have you understood this? Whatever I have told right now? Yes, no, fast. Unless and until you understood this, there is no point in going further because whole the second section is based on this concept. Only pre-stress you are going to learn in the second section. So I will repeat it once again. If you don't understand, please let me know. Give me the reply fast. Do you want it to repeat it? Do you want me to repeat it again, or shall we move further? Anybody, you can switch on, unmute yourself. You can talk, or you can give me reply in the chat also. Fast. Don't waste the time. What is the point in wasting the time? You have to just tell yes or no, repeat it or do not repeat it. If you don't understand this point, then there is no fun in going further. Okay. Let me know. Is it okay? Okay. Direction of load is vertically downward always. Okay. Due to that vertical direction load, what is happening now? See, the beam is horizontal on which the vertical load is there. Due to this loading, what will happen? Direct stress is getting introduced. Direct stress, you know that we always calculate it by P by A. Okay, that is the direct stress. Then the second thing is that due to that direct stress, now see if the load is vertically downward. I will draw the diagram so that it will it's easy for you to understand. See, this is the beam. Okay. Now your load is acting vertically downward like this. Okay. The downward load is acting on this beam. Okay. Point load is there. Also the self weight of the beam is also there. Okay. So due to which what is happening? Due to which there will be the generation of the stresses. You know the direct stress P by A, it is as it is, but here if you see due to this type of loading, the shape of the beam, if the beam deflects, then it will deflect in this way. I will draw the shape of the beam. It will deflect in this way. Okay. So if you see now carefully, compression is at top and tension is at bottom because the here it is the neutral axis of the beam. Here it is the neutral axis of the beam, and here the neutral axis will remain as it is. We assume that always the fiber which are on the neutral axis are neither subjected to compressive stresses nor subjected to tensile stresses. This we already know. This is our neutral axis. Okay. So the fibers which are above the neutral axis are subjected to compressive force. Generally, when the load is acting vertically downward, generally subjected to compressive stresses. And the fibers below the neutral axis are generally subjected to tensile stresses. So now what is the purpose of the prestressed concrete beam? Now what we do in the prestressed concrete beam, see, this bar is, if I extend this bar, suppose now, if this bar is taking out of the beam, okay, it is initially placed like this, and then we apply force. Okay, we apply the force on this bar. Okay, we apply the force. Let us say that the force is P. The applied force is P. Okay. Now this is prestressed concrete beam. Prestress. I am talking about the prestress. This prestress. We apply it. So what will happen while applying this? How to apply that is we will see in the after coming bits and next unit. But just now for time being you understood this. We apply the force on this tendon. And so that what will happen, this generally due to load this type of profile will gets developed for the beam. So this application of the load introduce some stresses in this steel. Okay, introduce some stresses in the steel, and these stresses are transferred to the concrete. These stresses are transferred to the concrete, and these whatever the generated stresses are there, these stresses are in the opposite direction of this profile. Okay, so this will try to counteract the stresses which are developed due to the loading, and this type of structure and this type of member is called as prestressed concrete member. That is the difference between your normal beam and prestressed concrete beam. Okay, or normal member and prestressed member. So we introduce the stresses in planned manner. That is the important. Okay, we introduce the stresses. That is the important point. Okay. Any other doubt? Is it clear? Roll number 56. Is it clear? Okay. Okay. So now once again we read the definition, and then we will see some the introductory points about the prestressed concrete. So here a prestressed concrete member is a member. Listen it carefully. A prestressed concrete member is a member of concrete in which internal stresses are introduced. Now, how we introduce the internal stresses? By applying the force on this tendon. Okay, by applying the force on this tendon. And we cannot apply the force manually. For that, there is one assembly, jack assembly is there. Okay, jack assembly is there. You can search it on the Google also. You will get the images of that. Jack assembly is there, which is used to apply the force for the tendon in prestressed concrete members. Okay, so internal stresses are introduced. So after application of this forces, the stresses, internal stresses are introduced in a planned manner, so that the stresses resulting from the loads are counteracted to desired degree. So not totally all the stresses are getting nullified. It is not always the case that suppose now due to the loading, suppose now due to the loading, 100 megapascal stress is getting developed due to the loading. And by introducing the internal stress in the prestressed concrete, it is not guaranteed that it will counteract 100 megapascal. It may counteract 80, it may counteract 70, it may counteract less than that also. Okay, we cannot say that. And so here the wording is that the stresses resulting from the loads are counteracted to desired degree. Okay, are counteracted to desired degree. This is prestressed concrete member. Okay, this is the definition of this. Now we will move to the further part. Now some important points for the prestressed concrete member. Why we all go for the prestressed concrete member? What is the need to go for the prestressed concrete member? So the basic need is what I want to tell you that, see, in the prestressed concrete member, what is happening? You know that concrete is very strong in compression, but concrete is very weak in tension. Okay. So whenever the downward load is coming on the member, due to that load, I have right now I have already shown you how the shape of that beam. Okay, when the resistors are acting on that beam, the fibers above the neutral axis are subjected to compression. Fibers below the neutral axis are subjected to tension. So concrete is very strong in taking the compression. But whenever the high load comes, the beam may be failed diagonally due to the heavy tensile stresses also. Okay. So to counteract this problem, to overcome this problem, normally you can see that the heavy girders are used for the bridges. If you see the bridge construction, normally the heavy girders which are used for the bridges are nothing but the prestressed concrete girders. Okay, those are the prestressed concrete girders. After prestressing, the compressive as well as the tensile strength of the member is increased. Okay, prestressing is the process. Understand this. Prestressing means pre-stress. You can separate those two words. Pre-stress. Okay, stress you already know. Pre means before. Pre means before normally. Pre-stress. Okay, so we introduce the stress in that tendon. That is the pre-stress. So due to which its compressive strength as well as its compressive tensile strength is getting increased. That is why we use these pre-stressed concrete members in the heavy bridges. The bridges which are carrying heavy loads, which are having very wide span. There we don't use the normal beams. Remember this. There we don't use the normal girders. Our normal girders of M20, M25, it is not used over there. Okay, to sustain those heavy loads, we use this stress concrete members. Okay, so now moving further so that you will understand. Concrete has a high compressive strength as compared to its low tensile strength. This point you already know. Okay, concrete is having a very high compressive strength as compared to its low tensile strength. Okay, so it is not difficult to make a concrete which can have a strength over 40 Newton per mm square. Okay, on 150 mm cubes after 28 days of curing. Okay, so now this sentence, half of this sentence. What this sentence tell us? We are saying over here that it is not difficult, so we can make, it is not difficult means we can make a concrete which can have a strength over 40 Newton per mm square. Okay, so you may heard the name of the concrete, high strength concretes and all those things. Mixed design we do. Okay, so we can achieve the compressive strength of the concrete above 40 Newton per mm square. So above 40 Newton per mm square also we can achieve the strength of the concrete. Okay, in the lab if you test, you know, in the lab we always take the 150 mm cubes. You know that those molds there are there with us in the city lab also. We perform the experiments on this. So if we cast the cube of 150 mm, okay, and after the curing of 28 days, after the curing of 28 days, it gives the strength 40 Newton per mm square or above that. That we can make. म्हणजे आपण हे करू शकतो असं सांगतोय. Okay, so we can achieve this much of compressive strength. Okay, but what is the further point says? But it is very difficult to obtain the tensile strength greater than 2.5 Newton per mm square. See, what is the number here? 2.5. What is the number here? 40. Compressive strength we can achieve more than 40 also we can achieve in the case of compressive strength. But if you talk about the tensile strength, it is near about 2.5 to 3. See the huge difference, huge gap. Okay, so concrete is very weak in tension. Okay, this is why the concrete is reinforced with steel bars in such a directions where the tensile resistance has to be offered. आता तुम्हाला क्लिअर झालं का की नॉर्मली मला असं nobody has asked me the question. I have taught to you some also, this is also in that way. Why always steel is mixed with the concrete? Why the other material is not taken instead of steel? Aluminum is there, brass is there, many metals are there. Okay, why we take the steel along with the concrete? So the reason is the steel is having the high tensile strength than the other material. And what is our requirement here? Our requirement is we are very strong in compression when we talk about the concrete structures, but its tensile strength is very low. So to enhance its tensile strength or to raise the here to enhance the tensile strength, what we do, we provide steel bars where there is a need of offering the tensile resistance. So where at the point where the tensile stresses are getting developed or tension is getting developed, to offer the resistance to that tension, we provide the steel bars. Okay, we provide the steel. Why we provide the steel? Because the steel is having very high strength. Okay, high tensile strength. I hope now these 2 points are clear with you. If you have any difficulty, you can ask me. Very simple points are there. The next is, in the reinforced concrete members, due to the low tensile resistance of concrete, a large quantity of steel is provided. Okay, so you always know that we also design, we always calculate the area of steel AST. We are having that long formula. From that formula, we calculate the quantity area of the steel in mm², and then we calculate the number of bars, and that much quantity of steel is provided. Now, while designing the footing, you see that we provide almost 15-16 bars. Okay, in the footing of size is having around about uh, 2.5 meter to 3.5 meter or 4 meter. Okay, so you can see that we are providing the high quantity of steel. Why we provide the high quantity of steel? To resist this tensile resistance. Okay, tensile stresses where it is needed. Okay, so that the entire tensile resistance is offered by the steel reinforcement. Okay, whatever the tensile resistance is there, as you see that concrete is very weak in tension, so concrete will not provide any tensile resistance. Whatever the tensile resistance is there, it is provided entirely by the steel. Okay, so no special means are provided to prevent the concrete offering the tensile stresses. So we have not made any special arrangement, or we have not enhanced the property of the concrete so that it can also provide the tensile stress. Okay. Work is going on that. Some research work is going on how to improve the tensile strength of the concrete, and how we can make a concrete which can resist the tensile stresses also. But right now, up to till date, there is no any special means which are provided to prevent prevent the concrete offering the tensile stress. Okay, so in the prestressed concrete member, so these 3 points, first 3 points we have talked in general about the concrete and steel for the normal beams. Okay, concrete and steel for the normal beams. These are first three are the general points which we have discussed right now. These first three paragraphs. Okay, is there any difficulty in these first 3 points? Anybody is having any doubt, any difficulty? In the first 3 points? Any doubt is there? Just 1 minute. Okay. So shall we move further? Yes, no? First, we have discussed right now first 3 points in general points. Okay. Now we are going to discuss about prestressed concrete. So here in general discussion was there that the concrete is high, having high compressive strength, low tensile strength. Okay, we can achieve the strength of the concrete 40 or greater than 40 Newton per mm square also of the after 28 days. But its tensile strength is very less. We cannot get the tensile strength more than 2.5 Newton per mm square generally. So that is why steel is combined with the concrete. Okay. So in the concrete, we kept the steel in large quantity, as there is no special provision we have made that the concrete can resist the tensile stresses. That is why we provide the larger area of the steel, okay, to resist the or to offer the tensile resistance. Okay, so these points we have seen up till now. Now, if we move further, In prestressed concrete members, all above weaknesses and defects are made up. Okay. So in prestressed concrete members, these weaknesses and defects are made up, means are overcome. Okay. So, now at this point you may ask me the question: if the prestressed concrete member is such a good that all these points which we have discussed in first three, those are overcome due to prestressed concrete, then why the prestressed concrete is not used in the normal construction also? That must be the question. Okay. So why it is not used? Because it is very costlier. Okay. The assembly which is required to generate that internal stresses and all those things, that is very costlier. So the cost of the prestressed concrete is very much higher than our normal members of the same dimension. If you take the cost comparison of prestressed concrete and our normal concrete block of the same dimension, same reinforcement, then the cost of this prestressed concrete is more as compared to the normal member, our normal concrete member. And also generally the prestressing is helpful when the size of the member is large and large girders are there. Okay, we do the prestressing on larger level. Okay, it is not suitable to apply the prestressing for small size members or on the small scale. Okay, where there is a large demand and large scale production is there, at that time only we go for the prestressing, because otherwise if we used it for the normal our residential commercial complexes and in our daily construction, then what will happen? The cost of the construction will get increased. The cost of the construction will get increased means you cannot imagine that it may go up to more than double triple. I don't know, depending upon the size, but it's definitely going to be increased. That is why it is not used. Okay. And the normal our concrete members, which we generally made up of the steel and concrete, those are sufficient for our residential and commercial complexes. Those can take the load of that. So there is no need for that. There is no need to go for the prestressed concrete members. Why we generally go for the heavy bridges, heavy girders are prestressed girders? Because on the bridge, if you see, bridge is a heavy structure. It is having its dead load, very much heavy dead load. Okay, which can be greater than our residential complex and commercial complex. And also, if you see on that bridge, there is a moving load is acting on the bridge. Now, suppose a bridge is start from this point and end at this point, then the vehicle is moved from this point to this point. So this is the moving load which is acting on the beam. It is not the acting on the bridge. It is not the stationary load which is acting. Okay. If you see, while designing our residential building and commercial building, we generally take the load, dead load, and then the live load which is there, we take it as a stationary load. Okay. And even though if the moving load is there inside the building, humans are there. What is our live load? Okay, we don't produce any vibrations. You know that while walking, we smoothly walk. We don't provide any vibrations or any excess load other than our weight. Okay, so uh, there is not much more live load also. But in the case of bridges, you see that the live load means the traffic load. It is there, moving load is there. Okay, and you can see when a car is moving, when a truck is moving, you can feel the vibrations also. Okay, so that forces is also acting over there. So to counteract all these things, generally we girders which are provided over there are the prestressed concrete girders. Okay, so have you understood now? If it is very good, then why it is not used in our daily construction? So this is the reason why it is not used. Then the next thing is that a prestressed concrete member is essentially a concrete member only, and the steel reinforcement are considered as the necessary device to supply the prestress to the concrete. Okay. Now this pre-stress, how do we supply to the concrete? So I have already told you. We introduce the internal stresses in the tendon, that is bar, in a planar manner. Okay. And now you know that steel and concrete are close to each other, means they are in contact with each other in a member. So once you apply the stresses to the tendon, that is to the steel, it will get automatically transferred to the concrete. Okay, it will automatically get transferred to the concrete, through steel to the concrete, as they are in the contact with each other. Okay, so this steel bars are apply, or steel reinforcement is act as a device to supply the prestress to the concrete. So it is supplying the prestress to the concrete. How it is supplying? Because externally we are giving some forces on that steel, and so that the stresses are getting generated in the steel, introduced in the steel, and from steel it is given to the concrete. So if I draw the diagram of this, where should I draw? Okay, here I will draw. This is the beam, and the tendon, suppose now this is the bar. Okay, and what we generally do, we apply the pre-stress over here. Stress in force P. Okay, now the internal stresses you can see over here. The internal stresses first in the steel bar. Okay, here in the steel bar, the internal stresses are getting developed or introduced. Internal stresses. Okay, now the concrete is surrounded to the steel. Okay, if I draw the concrete, concrete is somewhere here. Here, all the things are, these things are the concrete. This is the concrete. Okay, so concrete is here near to this steel, so that the whatever the stresses are getting developed in this steel, okay, those are transferred to concrete. Those are automatically transferred to concrete. So here they told that it generally acts as a, it is act like a device which can transfer the stresses to the concrete. Okay, this is the this point. A prestressed concrete member is essentially a concrete member only, and the steel reinforcement are considered as a necessary device to supply the prestress to the concrete. I already told you how that the prestress is supplied to the concrete. Okay. Now, to get the maximum advantage of prestressed concrete, the prestressed concrete members, it is necessary to use high strength concrete and also high tensile steel. Okay. So to get the maximum advantage, of prestressed concrete, okay, it is very necessary to use the high strength concrete. Okay, so you have to use the high strength concrete and also high strength steel we need to use. Okay, then the concrete used for prestress work should have a cube strength of 35 Newton per mm square for post tension system and 45 Newton per mm square for pre-tension system. These are the different systems of prestressing: pre-tension and post tension. This is the way, or one of the methods by which the we can achieve the pre-stressing. Okay, this we will see in the upcoming bit or in the next unit. What is the post tensioning and what is the pre-tension? Okay, so tensioning means, from the name itself you can know that post means after, pre means before. Okay, so before pouring the concrete, if we have introduced the internal stresses in the pre-stress member, then this is called as pre-tensioning. And the post-tensioning is after the concrete is poured, then we apply the internal stresses, then it is called as post-tensioning. So this we will see in detail in the coming bit. I have just given you the introduction. So here this point can be asked for the MCQ also. So this is the important point. See here, what is mentioned over here? The concrete used for pre-stress work should have a cube strength of 35 Newton per mm square for post-tension system. Okay, for post-tension, what is the minimum strength? 35, and for pre-tension, 45. ओके, एवढी क्यूब स्ट्रेंथ असायलाच पाहिजे कॉन्क्रीटची. then pre-stressing is useful. Okay, so these are some introductory parts about the pre-stressing. So next is the classification of the pre-stress. Classification of pre-stressed concrete members. Okay, so see here some classification is given. Classification of pre-stressed concrete member. So it is classification is done by many ways. Okay, so it can be done like this also: externally and internally pre-stressed members, linear or circular pre-stressing, pre-tensioning and post-tensioning. Here you can see these words: pre-tensioning and post-tensioning. Okay, so these are the classification of pre-stressed concrete members. Okay, so before moving to the classification, now just I have told you the introductory part of the pre-stressed concrete member. Okay, this is the introductory part. Okay, so this part is very important. Okay, and how do we apply the stresses? And see here the diagrams are given. Further, we see that how we apply the stresses and all those things. But my main concern is with this now. Okay, so this is whatever the introduction I have told you just right now. I hope now that introduction is understood to you. Okay. So the key points here, I will tell you the key points. What are the key points? Okay. First thing is concrete is strong in compression, very weak in tension. We can achieve the concrete, the compressive strength over than 40 Newton per mm square, but we cannot achieve the tensile strength more than 2.5 Newton per mm square. Okay. So that is why what we need to do, we always provide the steel in heavy quantity in any member with the concrete so that the tensile resistance, they can offer the tensile resistance. Okay, so these types of things we are doing in our normal concrete. So to overcome this, what we can prestressed concrete members are used. Okay, so while using the prestressed concrete members, the main points are, what are the points here? The tendon or the steel reinforcement is there. On that steel reinforcement, we apply the force. Okay, we apply the force on the reinforcement which are placed at the bottom of the beam. Okay, due to this application of the force, the internal stresses are getting developed in that tendon or in that reinforcement, in that bar. Okay, and those internal stresses are transferred to the concrete, and those internal stresses are transferred to the concrete. And why we do that? Because after introduction of these internal stresses, these stresses will counteract the stresses which are developed due to the loads. Stresses, direct stress and bending stress, these are the stresses which are developed due to the loads. These stresses are counteracted to the desired degree by this internal prestressing or internal stresses. So that is why we do the prestress. Second most thing is prestressing is not the economical. The cost of the prestressed member is very high as compared to our normal members, normal beams, columns, whatever you have seen in your day-to-day life. So that is why we have not used the prestressed concrete members while we are constructing a residential complex, a home is there, or a commercial complex are there, or small structures are there, due to its cost. Okay. And normally large in the large structures like bridges, minor bridges, major bridges, heavy girders which are used are the prestressed concrete members. And the last one, the point is that the concrete which are used for the prestressed work, okay, that should have a cube strength of 35 Newton per mm square for post tension system and 45 for pre-tension. In objective, this may be asked. Okay, this is very important. Remember this. Right? So this is all about the prestressing. Now further we will see what are the classification of prestress, and that the diagram I will show you how the forces are applied to the tendons and how the internal stresses are getting developed in the prestressed members. Okay. So after this introduction now, before moving further, we will take some introductory parts of our triple P system, and then we will move further. Okay. So I will share the whiteboard now. Okay. So first of all, the syllabus of this is our section 2. Okay. And here the methods of pre-stressing. The name of unit is methods of pre-stressing and its classification. Okay. Here first we will see what is the syllabus. What is the syllabus? The syllabus is introduction, introduction to pre-stressed concrete, to pre-stressed concrete, concepts, concepts, systems, systems and methods. Samely use these two words, systems of pre-stress. Okay, this is our syllabus. Then next point is about title of chapter. About title of the chapter. Okay. So about the title of the chapter, if I write the concept of prestressed concrete, take the notes of this also, write it down. This is also important. Once you read this, you will come to know that what you need to learn from this unit and what is required. Stress concrete, advantage of prestressed concrete, its classification, its classification, and various systems, and various systems. Then methods of prestressing for pre-tensioning, and post-tensioning members are explained in detail. Okay. Chapter, these are the things are there. The next is the importance of chapter in the subject. what is the importance of this chapter? That we will see. Okay. So now this chapter is basically deals with the basic fundamentals of the prestressed concrete and various methods of prestressing. Okay. In today's life, the bridge decks are prestressed concrete members. Have okay. Hence to study this prestressed members is very essential. Okay. Now, who knows in upcoming time, this our normal conventional concrete is replaced by the prestressed concrete if the cost economy is achieved over the prestressed. So this is why we have to learn this. Okay. Now the importance of the chapter in the subject. So here I will write this chapter deals with basic fundamentals, basic fundamentals of of prestressed concrete and various methods of prestressing and various methods of prestressing. In today's life, in today's world, the bridge decks, girders, etc., are prestressed concrete members. Prestressed concrete पाणी दे म्हटलं. Prestressed concrete members. Okay. Hence, hence, study of study of methods of prestressing is essential. Is essential. Okay. Then next point is central idea. Central idea of the chapter. Okay. The prestressed concrete member the central idea of the chapter. So here, prestressed concrete concept is growing very highly this chapter mainly focus on the basic concepts of prestressed and various various systems of prestressing various systems of prestressing along with its methods along with its methods. Okay, just 1 minute. The next is the chapter outcome. Chapter outcome. Okay. So after successful completion of this chapter, successful completion of this chapter, students will be able to first able to understand. First point is understand the fundamental concept of prestressed concrete. Second, second, students will be able to classify classify the various types of prestressed concrete members. And third one is after completion of this chapter, student will be able to know thoroughly thoroughly the different methods the different methods the different methods of prestressing prestressing for for pre-tensioning and post-tensioning. Okay, so these are your chapter outcomes. This you should learn or you will get after completion of this chapter. Okay, so introductory part and this our triple P part is covered now. Now we will move further to the classification, and in between if required I will use this whiteboard. Okay, so we will move to the PowerPoint presentation again. So classification of prestressed concrete members. Okay. So there are basically it is divided into first three categories. How it is classified. Okay. So some base should be there now for classification. So on this basis it is classified. So these are the three bases A, B, and C. First, the classification is done on externally and internally prestressed members. Okay, so we apply the prestressing force, that is externally or internally, depending upon the classification is done. Second is linear or circular prestressing. Linear prestressing means in straight line prestressing. Circular means circular. You see the water tank. Okay, prestressed water tanks are also there. So, or sometimes circular structure is there, circular arch is there, and you can provide the circular prestressing also there at that time. And third base is this much: pre-tensioning and post-tension. Okay. Third is this pre-tensioning and post-tensioning. So we will see all of this one by one. Now you will get cleared with the things. See how it is applied and what is happened. Now here the procedure is explained how exactly it is applied. Externally and internally prestressed members. First classification. So here you can see, here you see the member. This is your prestressed member. Okay. Here the support is provided. Here the support is provided. Here it is kept like this. Not necessary it should be kept like this. Okay, that I have shown the diagram. Okay, in that way. Then this is called a jack assembly. Here one bearing plate is also there, and this assembly is called as the jack assembly. Okay, here on the both the sides plate is there, and here the jack. Jack is nothing but a instrument which can use to what we can say apply the prestress to the tendon. Okay, so now here see externally and internally prestress members means here direct to the concrete member the prestress is applied. Here the prestress is not applied at the tendon. You can see here directly on this member. This total is the concrete member, and here the prestressing force is applied with the help of this jack assembly. Okay, and these are the abutments. Abutments means a permanent support. Permanent म्हणण्यापेक्षा support, a strong support. That we called it as the abutment. Here you can take that term in that way. Okay, so we will see here. A member can be prestressed by external reactions offered by the rigid abutment is called as the external prestressing. So whatever the reactions here offered by this abutment, that is, this is the permanent support due to which the pressure is force is acted on this concrete member, okay, prestressed member, and the prestress is getting introduced. So the point here is that in the external prestressing, instead of providing tendon, okay, बघा इथे नीट काय लिहिले ते नीट वाचा. In the external prestressing, instead of providing the tendon from which the prestress can be applied, the necessary prestressing force can be applied by compressing the member by jacking against the abutment as shown in figure. Okay, so normally how do we apply the prestress? Normally what we do in a prestressed concrete member, we apply the prestressing force to the tendon or to the bar or to the reinforcement. Okay, and then that is transferred to the concrete. I have shown the diagram also. Okay, but here in this prestressing, what they do, they directly apply the prestressing force on the member itself. Okay, they are not applied to the steel, they've directly applied on the concrete. Okay, so the necessary prestressing force which is applied through this jack assembly, okay, and it is applied by compressing the member by jacking against the abutment. Okay, so इकडनं पण force apply केलेला आहे, या साइडने पण force apply केलेला. Okay, so in this way the internal stresses are getting developed in this prestressed concrete member. Okay, a member can be prestressed by tensioning the tendon is called as internal prestressing. So internal prestressing and external prestressing. So I will tell you once again here on this whiteboard. See, generally, now if I draw the diagram, this is the beam. Okay. Then this is the tendon. Tendon means reinforcement bar. And then we apply the prestressing force. This is our prestressing force, like this. Okay, this is your prestressing force. Now this P is applied. Where P is applied? P is applied to the steel reinforcement. P is applied to the steel reinforcement. This we called it as bar. This we called it as tendon also. Okay, and from here, once this tendon is compressed by using this prestressing force, the stresses are getting developed, induced over here, internal stresses, and those stresses, these internal stresses which are getting developed in this bar, those stresses are transferred to the concrete. Those stresses are transferred to the concrete. In this way, the prestressing done. This is called as internal prestressing. This is called as internal prestressing. Okay. And now what is external prestressing? External prestressing is just now you have seen the diagram. Okay. It is directly prestressed. A member is directly taken. Okay. So suppose now this is the member. This is the member which is taken directly. Okay. So this is the member. And now from to member itself, here the force is applied. Here the force is applied by using the jack. Okay. So here these my hands are the bearing plates. Okay. So after that here the jacking will be there, jack assembly is attached, and beyond that the abutment is there, firm support is there. So the compressive force is acting in this way here. On the member itself, whole member, this is made up of steel and concrete both. And on this it is acting. Okay. So this type of prestressing is called as external prestressing. Okay. And first, which I have told you, we apply the prestressing force to the tendon, that is called as internal prestressing. That is called as the internal prestress. Okay. So this is the basic difference between external prestressing and internal prestressing. Okay. So now, then the similar linear or circular prestressing. What is linear prestressing and what is circular prestressing? So the term circular prestressing is applied to the prestressed circular structures like cylindrical tanks, silos, and pipes. Okay. In these cases, the tendons are provided in the form of ring. Okay, so circular by name itself, you can say that if the shape of that structure it is like cylindrical, circular, so the reinforcement in that is also cylindrical or circular. So whenever the reinforcement is cylindrical or circular, we provide the reinforcement to that. We provide the prestress to that reinforcement, which is circular or cylindrical. So that type of prestressing is called as circular prestressing. Okay, and where it is mostly provided, you know that cylindrical tanks. I have already talked about the water tanks. Okay, then silos and pipes. Okay, and pipes. So where this prestressing is done, it's called as circular prestressing. Next thing is linear prestressing. So what is the linear prestressing now? Linear prestressing is a term applied to prestress the straight members such as beams, slabs, etc. Okay, the members which are straight. Beam, you know that beam is a straight. So in the beam, you can see that horizontal tendons are provided like this. Bars are provided. So when you prestress those bars, that is called as linear prestressing. When you apply the prestressing force on that bar, okay, then that is called as linear prestressing. Circular shape मध्ये असलं तर त्याला circular म्हणायचं, linear shape मध्ये असलं तर linear prestressing. Normally linear prestressing is mostly used. Next one. These are the important. This is the important classification: pre-tensioning and post-tensioning. Pre-tensioning and post-tensioning. It is the important classification. See, we will understand now what is pre-tensioning and what is post-tensioning. First is the pre-tensioning. Okay. So in pre-tensioned members, the tendons are tensioned even before the casting of concrete. So in the first line itself, they told you that what is the pre-tension members or what is the pre-tensioning. What they have told us, in pre-tensioned members, the tendons are tensioned even before the casting of concrete. So means what? Means what? Now suppose we want to cast the beam. Okay. So for the casting of beam, what we do? We generally lay down the formwork. Suppose now this is the formwork. This is not the beam stick. Now what we first do, we place the steel reinforcement. Then we place the cover at the bottom. You know that this is not a beam. This is the what you can say formwork. Now I want to cast the prestressed beam. So this is the formwork. So below this here on the side and at the bottom we provide the covers. Okay, 35 mm, 30 mm, 25 mm cover depending upon the design we provide the covers. Okay, here the covers are provided. Then we lay down the steel reinforcement. Okay, so आता ही जे मी स्टीलचे बार प्लेस करणार तर कसे करणार तर थोडा बार इथनं बाहेर यायला पाहिजे ना. ओके, पूर्ण इन टू इन कट नाही, हा बार असा असणार आहे. Are you getting my point? Whatever the bars we are placing, those bars will come. The formwork like the hole केलेलं असते. The hole is made in this formwork so that those bars can come out of that wooden block. Formwork हे woods असते. Okay. So now after this, what we do? We apply the prestressing force over here. Okay. So I will show you. So on this tendon, the prestressing force is applied. Okay. On this tendon, this prestressing force P is applied, and after we achieve the certain our value of the prestressing, what we will do? We will remove this prestressing force. We will remove this prestressing force and we will cut down the tendon. We will cut the tendon from this part. Okay, we will cut down the tendon from this part. Whatever excess part which are outside, what we have taken to apply the prestressing force, that part will get cut down. Okay, and now whatever the tendon is there in this tendon, now the stresses are introduced in this tendon. Okay, now the stresses are getting introduced in this tendon, and these stresses are getting introduced in the tendon before pouring of the concrete. अभी तक हमने concrete नहीं डाला है. Before pouring of the concrete, so this is called as pre-tensioning. Pre means before pouring of the concrete. So this is called as pre-tensioning. Okay, so these stresses are getting developed. Internal stresses are getting developed over here. Okay, and now after this, the concrete is poured now. Okay, now concrete is poured up to this level, and now again the formwork is laid down and it is left for the curing. Okay, so this type of prestressing is called as pre-tensioning. This type of prestressing is called as pre-tensioning. So if you see further, so pre-tensioning, in the pre-tensioned members, the tendons are tensioned even before the casting of concrete. Okay, just I have told you. One end of the tendon is secured to an abutment, while the other end of the reinforcement is pulled by using jack, and then it is fixed to the another abutment. Okay. एक end बघा. So this is the one end. This is fixed to the abutment. This is, you can see, this is the tendon. This is the steel bar. Okay. This is the steel bar. This is the tendon. And now this is fixed to the abutment. This is fixed to the abutment. And what is done now? So at one end it is fixed to the abutment, at other end it is fixed to the abutment, plus jack assembly is attached here. Okay, jack is attached here. ते आपण ह्याचं असतं बघा, if you are seeing the four-wheeler and there, if that four-wheeler is punctured, what the mechanic will do when you go to the puncture shop, that mechanic, he will first place the jack, okay, below the tire, and then he rotates that and your car gets lift. Okay, so after rotating that, something mechanism is done so that some rod will be there inside that jack, and that will lift the, what we can say, vehicle. So त्याचे left करतानाची process आहे ना, when it is move your vehicle upward direction. ओके, पंक्चर काढण्यासाठी चाक हवेत पाहिजे ना तुमच्या गाडीचं, फोर व्हीलर जरी असली तरी. ओके, तर ते करताना त्या जॅकला काहीतरी फोर्स लावावा लागला असेल की नाही उचलायला. जॅकला काहीतरी फोर्स लावावा लागत असतं नाही. सिमिलर टाइप ऑफ असेंब्ली इज देअर. आय एम नॉट टेलिंग यू सेम टाइप. I am just trying to explain you the concept working of jack. Similar type of mechanism is there here in the jack, by which the force is applied on this tendon. Okay, so that the internal stresses are getting generated. Okay. So here, now after this, here you can see the prestress is applied. And the concrete is now poured. After the concrete has cured and hardened, the ends of the reinforcement are released from the abutment. मी तुम्हाला आताच सांगितलं. ह्याला prestress दिल्यानंतर, once you transfer the prestress to the tendon, then the concrete is poured. Once this, we wait for the concrete to harden up. Once this concrete is hardened, this will cut down from here. Okay, from this point, from here, here means from, it is cut down just after the beam here. From here it is cutting down. इतना कट केलं जाते, so that you get this. Okay, the reinforcement is now tends to regain its original length, and it compresses the concrete surrounding it by bond action. Okay, the prestress is thus transmitted to the concrete entirely by the action of bond between the reinforcement and surrounding concrete. Okay, by the bond between the reinforcement and surrounding concrete, that we have already seen. Once this prestress, internal stress are getting developed in this bar, it is automatically getting transferred to the concrete. Okay, so this is the your pre-tensioning. This is your pre-tensioning. Anybody is having any problem in this pre-tensioning? Any doubt in this pre-tensioning system? Let me know. Anybody is having any doubt? If no doubt is there, then you can tell me. Shall we move further? पुढचा पॉइंट घ्यायचा का? Shall we move further? Let me know. You can tell me in the chat also. इधर उनको बोलो लेक्चर चल रहा है. ठीक है. देशमुख सर, आप फ्री हो क्या? करो नहीं नहीं, वो आप इसको डीएसवाई को जाके बैठ रहे ना, इसलिए मैं उधर जाके बैठता था। अगर कुछ तो काम रहेगा इधर बैठ के करने जैसा तो इधर से कर। उनको पूछेगा क्या काम है, सुनाने बैठा है ना तुम इधर में। एमटेक का एमटेक के लिए जा रहा हूँ मैं, एमटेक कोऑर्डिनेटर आप है ना, आपको इधर टाइम बिजी इसलिए मैं जा रहा था उधर। हाँ बैठ के करने। हाँ नहीं नहीं, इधर काम रहा तो उनको बोलो इधर करेंगे, फिर नहीं तो मैं लेक्चर के बाद क्या करने वाला, मैं जाता फिर लेक्चर में। ऐसा नहीं बोलूंगा, मेरे को कंप्यूटर आता नहीं, मैं काम को थोड़ी आ सकता हूँ। करते रहता हूँ। ओके, सो is there any doubt? Nobody is replying. Why? Hmm? Is there any doubt whatever I have told you right now? Is there any doubt in this? Things are easy. I know the concepts are not so much difficult, but still, if you say yes, no, then we can move further. No? Hmm? Yes, no. Shall we move further? Okay. So the next point is post tensioning. Okay. The post tensioning means, now you can easily tell that post tensioning means after pouring of the concrete, the tendons are tensioned. That is nothing but the post tensioning. So post tensioning, a post tension member is a one in which the reinforcement is tensioned after the concrete has fully hardened. So here what we do in pre-tensioning, first we apply the pre-stressing force to the tendon before the concrete poured. Okay, and here what we do, we we apply the pre-tension, we apply the pre-stressing force to the tendon after pouring of the concrete, after it is getting harder. So that is the first basic difference. So here a post-tension member is one in which the reinforcement is tensioned after the concrete has fully hardened. After the concrete has fully hardened. The beam is first cast, leaving the ducts for placing the tendon. The ducts are made by leaving the steel tubes in the concrete. So, first of all, the beam is cast. Okay. So now see, a concrete beam is cast totally, and in that beam we left some holes to provide the tendon. म्हणजे ही जी beam आहे, suppose this is the beam. Okay. This is concrete beam fully casted, but here there is a hollow tube is there. It is like a tunnel. Tunnel बघितलं ना कसं असतं डोंगरातनं. Okay. So hollow tube is placed inside. Hollow tubes are placed first, and then the formwork is there. Formwork is there. Then hollow tubes are placed at the places where we want to insert the prestressed tendons, and then the beam is cast. Okay, and then the concrete is hardened. Once the concrete is hardened, where you have placed the pipes, okay, those portion will remain hollow portion. Where you provide these pipes, those portion will remain hollow portion. Pipes will be there. Okay, so that is what they have told us. The beam is first cast, leaving the ducts. That hollow portion is called as duct. Okay, leaving the ducts for placing the tendon. किसके लिए duct छोड़ा है? To place the tendon. Okay, we will place the tendon over there. The ducts are made by leaving the steel tube in the concrete. That I have already told you. Okay. We will place the tubes. The beam is first cast, leaving the ducts for placing the tendons. The ducts are made by leaving the steel tubes in the concrete. When the concrete has hardened and developed its strength, okay, when the concrete has hardened and it developed its strength, the tendon is passed through the duct. Then that tendon is passed through the duct, whatever we have left over there. Okay. So one end is provided with an anchor and is fixed to other end of the member. See here, one end is anchored. This is the anchor. Anchor plate is provided. And other end is fixed to the jack. Okay. And ये जो बीच में है ना ये, this is the tube, steel tube, and this is duct. So hollow steel tube. And here the tendon is placed. Then now the other end of the tendon is pulled by the jack. So here the tendon is pulled by the jack, due to which the tendon compresses the concrete. Okay. After the tendon is subjected to the desired stress, the end of the tendon is also properly anchored to the concrete. So इथून सुद्धा मग याला परत कट करून टाकलं जाते, anchored करून टाकलं जाते इथं. Okay. So a distribution plate is provided at each end to avoid the crushing of concrete due to excessive bearing stress. Now here the what we can say, bearing plate is provided. Bearing plate, why it is provided? So that the force will be transferred uniformly throughout whole cross section. Okay, so that is the role of that bearing plate. Why we provide the footing below the column? Why we don't directly raise the column on the ground? Because the column is having a high length. Length is high as compared to its cross section. So when you directly raise that column on the footing, sorry, on the soil, then it will try to punch through the soil also. Okay, and due to the heavy length, the surface area of the column is less as compared to its length. So the area of transferring the load become reduced. It is getting reduced. So that there are highly chances of that column is getting cracked due to the reaction from the soil. Same way, that is why we raise the column on the footing. And what is the basic purpose of the footing? Footing is having larger cross-sectional area. So whatever load coming from the column, it will distribute to the large area of soil. Same principle is here. When we apply directly jack assembly to the tendon, okay, and we apply the force over there, that due to that force now, it is possible that that force will not act uniformly throughout the whole cross section. Okay, so that is why what we do, we provide the bearing plate there. Bearing plate means a plate is there. Suppose now this is your beam, and here somewhere a plate is provided like this, of this shape, so that it will get transferred. The jack is not directly attached over here. Here in between, bearing plate is provided. Okay, to for the uniformity of the loading. Okay. And the by this way the prestressing is getting developed in the steel, and that is transferred to the concrete. Okay. So this type of process is called as post tensioning. This is the post tension. Okay. So the next part is the methods of prestressing. I will also share these notes with you. Okay. Right now, if you want, you can take the screenshots, or also you can write it down the important points. So systems of prestressing. So basically in the systems of prestressing, predominantly we will see the four systems. There are many systems of prestressing. Systems means methods to do the prestressing. Okay. So basically what we predominantly we will see these four systems. Pre-tensioning, you know that it is divided into two types: pre-tensioning system and post-tensioning system. So in the pre-tensioning, Hoyer system comes under the pre-tensioning, and in the post-tensioning means method. थोडक्यात सिस्टीम म्हणजे काय, मेथड. प्री टेन्शनिंग करायच्या मेथड कुठल्या आहेत, तर त्यातली मेथड एक आहे हॉयर्स मेथड. पोस्ट टेन्शनिंग करायच्या मेथड्स कुठल्या आहेत, तर त्यातली आहे फ्रेसेनेट मेथड, जिफर्ड उडाल, ली मॅकॉल. So all these are the scientists who have invented these methods. So their name is given to that method. Okay, how it is to be done. So now we will see one by one each method. First, in the pre-tensioning system, Hoyer system. Okay, so the Hoyer system is usually adopted for the production of You can see the Hoyer system is usually adopted for the production of pre-tension members on a large scale. If you want to pre-tension the members on a large scale, then this Hoyer system is adopted. Okay. This method consists of stretching the wires between the two bulkheads. So these you can see the diagram. These two are called as bulkheads. Bulkheads mana, abutment mana, one and the same thing. The purpose of all is to give the strong support. Okay, you can call abutment, you can call bulkheads. The function of the is them is same, to provide a stable, strong support. So the method consists of stretching the wires between two bulkheads at a large distance apart. So these two bulkheads are very largely spaced. They are not close to each other. You may imagine that one beam is there. So on the right hand side, one bulkhead will be there. Left hand side, one bulkhead. No, it is not the case. A large concrete bed is there. Large concrete bed is there, and at the ends of that, two bulkheads are there. So on that large concrete bed, 2, 3, 4, 5 beams you can cast at a time. Okay. So here that is why they have mentioned two bulkheads at a large distance apart. Okay. The concrete is now poured so that the number of beams can be produced in one line. Okay. So the formwork is laid out. Here I have shown the diagram in that three beams are casted at a time. So in the first point, they have mentioned that this method is adopted when you have to do the pre-tension on a large scale. Pre-tensioning on large scale. Large scale means more than one beam you can cast at a time. Okay, so this is the assembly of that. This is called as casting bed. These are the bulkheads. This is beam 1, 2, 3. This is the continuous tendon, and one tendon is passed through all the beams. This is the continuous tendon. So I have shown here one tendon. Number of tendons will be there, which are passed through the all the beams. Single tendon. Single means same tendon, not single. The word is same tendon. Okay. So here you can see that the concrete is now poured so that the number of beams can be produced in one line. Okay, so the concrete is poured. After the concrete has hardened, after the concrete has hardened, okay, so this after the concrete has hardened, this due to jack assembly, the pre-stressing is introduced in the steel wires. Okay, and the stress is getting induced in the wire. Okay, up to the desired degree, whatever we want, up to that we have introduced the stress. And we after that the wires between different units of the beam are also cut off. Okay, so the wires between the different units of the beams are cut off. Okay, and now once these wires are cut off from here, see, I can show you from here, those units are cut off. Okay, here from this point here. Okay, so and then whatever the pre-stress is developed in the tendon, that is transferred to the concrete. That is transferred to the concrete. So in this way, the pre-stressing is done. This way, the pre-stressing is done. This method is called as Hoyer's method. This method is called as Hoyer's method or Hoyer's system. Okay. So this system is the thing, but it is Hoyer's system. I hope now it is clear. Hoyer's system. So you can cast the number of beams at a single time. One tendon is passed through all the beams. Once the concrete is hardened, then the pre-stressing is applied over here. And after the application of the pre-stress, these wires are cut down. Okay, these tendons are cut down, and now they will become three beams with different tendons. And then that pre-stressing force is transferred, okay, to the concrete. This is Hoyer's system. Now we will see the post-tensioning system, that is the Prestressed system, Gifford-Udall system, and Lee-McCall system. So first is this Prestressed system. Okay, so we can see this. This is the diagram of Prestressed system. Okay, so this is the female anchorage with steel spiral. Okay, so this is like circular spiral. Okay, this is the duct former. This is the duct. Okay, and this is the high tensile wires. You can see the wires which are passed through this assembly. Okay, through this cone, these wires are passed. You can see over here. These are the high tensile wires. This is the duct former. And then this is the female anchorage cone with steel spirals. These are the spirals which are attached to the steel. And these are the tendons. म्हणजे इथून गेलेले टेंडन हे इथून बाहेर आलेले. Okay. And this is called as male cone, which is attached to the tendon. Which is attached to the tendon. Okay. So this is called as the Prestressed system. Here female cone and male split cone it is shown. So same here the male cone will be there, and this is called as the female anchorage. This type of assembly is there. Now we will see how it is applied. The Prestressed system was the first to be introduced among the post-tension systems. This can be also asked for the MCQ. MCQ ला विचारतात बघा हे. The Prestressed system was the first to be introduced amongst the post-tension system. High tension steel wires 5 mm to 8 mm in diameter and about 12 in numbers are arranged to form a group into a cable with spiral inside. Okay, so these are the cables which consist of 10 to 12 steel tendons. म्हणजे 12 किंवा 10 bars, 10 or 12 bars, they are taken together, steel bars, and they are kept in one cable. Okay, cable means you can see that cable means what? That is the cover to the wire is nothing but the cable. We can see that in our day-to-day life also, when we attach the cable wire to the TV, then now you can see all the channels. If you cut that cable wire, you will see a brass wire or copper wire. Sorry, not brass, copper wire inside it. Okay, and we see that this cable white is there to protect that wire, to protect us. It will act as an insulation. Okay, so same way, cable is there. Inside that cable, 10 to 12 tendons are inserted, which is having a diameter of 5 mm to 8 mm. Okay, that is what they have told us. The spiral springs are provide the clearance between the wires, and thus it is provide a channel which can be cement grounded. So this is the channel here, and in that channel it is the cement grouting is also done in that channel. Okay, the whole thing is enclosed with a thin metal sheet. So these are the thin metal sheets. The anchorage consists of cylinder with central conical hole, is provided with heavy reinforcement. So here you can see the central conical hole, and it is the reinforcement is given over here. The central hole passing actually permits the cement ground to be injected through it. The prestressing force, and now the prestressing force is applied over here. Okay, to this assembly, to the jacking. Jacking it is not shown over here, and then the prestressing is transferred to the concrete by high tensile steel wires because of bond action between steel and concrete. So in this way, the prestressing is transferred. In this way, the prestressing is transferred over here. Okay, so this is your Prestressed system. This is the Prestressed system, and last one is the Gifford-Udall system. Gifford-Udall, then Lee-McCall. Still two systems are there. Then we will move to the MCQ. So this is the diagram. This you have to remember this. See, this diagram you have to remember this. Okay. So in the examination, normally theory questions are not there on this, but for the MCQ purpose, it is required. Normally the numericals are asked in the examination, but still you should know the theory. It is not required, but I am taking it in the detail. So G for Udal system. So this system you can see here, this is the conical high tensile steel wire. So these are the steel wires. This is called as split cone. This is called as split cone, and this inside cone it is called as the female cone. This is called as female cone. This dimension is 25 mm. This dimension is 21 mm. Okay, and these are the bearing plates. These are the bearing plates. So this is Gifford Udal system. Here it consists of steel plates, split cone. Split cone, if you want to see, this is the split cone. This is the split. ही खाच असते मध्ये अशी. Okay, so this is the split cone, and this is the female cone. This is called as female cone, and this is called as split cone. So here it consists of steel split cone and cylindrical female cone anchorage to house the high tensile wires. The wires are stressed and anchored one by one in a separate cylinder using a small wedges. Okay, so wires are already tensioned, stressed by using a separate cylinder. The ducts are generally formed by metal sheets cast into the concrete member. So this is the duct which is cast into the concrete member. The ducts are generally formed by the bearing plates bears the thrust which can cast into the concrete. So these bearing plates which are provided over here, that bearing that bears the thrust, okay, at the casting of concrete. So here, then after applying the prestressing force to this, okay, the prestress is getting developed over here in this tendon. Okay, so this type of system is called as the Gifford-Udal system of prestress. We are prestressing the steel. हे स्प्लिट कोन आणि ह्या फिमेल कोनचे अरेंजमेंट बघा. या फिमेल कोन मधनं टेंडन पास केलेला आहे. तर या स्प्लिट कोनच्या मध्ये जे खाच आहे त्याच्यामध्ये हा फिमेल कोन बसणार आहे. Okay, and that split cone is surrounding to this female cone, and then the tendon is passed to that. So this is your Gifford-Udal system. If you want, you can take the screenshot of the diagram. All these are the manually drawn diagrams by me. So these are my notes. I will forward you these notes to you also. Then last one is the Lee-McCall system. So you can see that here the high tensile steel bars. Okay, this is called as nut. These are the washers. These terms we already know: nut, bolt, washers. So here nut washers are there. These are the end plates. These are the plates which are attached. Okay. Here the tendons used are high tensile bars of diameter varying from 12 to 40 mm. Again, this is the question for MCQ. In Lee-McCall system, what is the minimum diameter used? So it is 12 mm. 12 to 40 mm आपण यूज करतो म्हणून सांगितलेलं. Okay. After tensioning, each bar is anchored by screwing a nut and washer tightly against the plate. Okay. So in this system, the forces are transmitted by the bearing at the end plates. So these are the bearing plates. These are used to transfer the forces. Okay. It is not used for curved tendon. So only if it is used for the straight tendon this is used. It is not used for the curved tendon. So tendon which is taken out from here and then force is applied. So that force here it is applied whenever the prestress. It is applied to other end also by with the help of these end plates. Okay. So this is done in this Lee-McCall system. So with this, we have this third unit is the first unit in prestressed concrete is over. This is totally a theoretical unit. Okay. So I have told you every system, what is prestress, what is pre-tensioning, what is post-tensioning. We have seen higher system, we have seen Prestressed system, we have seen Lee-McCall system, we have seen Gifford-Udal system. Okay, then we have seen some points, introductory points for the prestressing. We have seen why the prestressing is beneficial. Okay, what are the defects in our conventional concrete members? All these things we have discussed right now in this unit. Okay. After this, we will move to the MCQ. This is the first MCQ. If you want, you can take the screenshot. This is very important. So, in a pre-tensioning system, so first MCQ, in a pre-tensioning system, the member is cast first, followed by the tensioning of the high tensile wires. Pre-tensioning म्हणले. So member is cast first? No, it is not cast first. The member is prestressed by external anchors? No, pre-tensioning is not the system of external, it is internal system. So no. And last one is the high tensile wires tension before the placing of concrete form. Okay. So in a pre-tensioning, pre म्हणजे before. So in a pre-tensioning, high steel wires are tensioned before the placing of concrete. Okay. So option C is the right answer. Next MCQ. Curved cables can be used in. Curved cables can be used in. Okay. Retention members, na use karat. Externally prestressed members, we cannot use curved cables. Post tension members, we can use the curved cable. In the post tension members, we can use the curved cables. Okay. In the post tension members. Now, so the answer is again C, post tension members. So in a long line method of prestressing, only one member can be cast, two members can be cast, several members can be cast. So the answer is several members can be cast. Long line method means Hoyer's method. The name, another name to the Hoyer's method is long line method. Okay. So the another name for Hoyer's method is long line method. So in I have already told you, you can cast beam 1, 2, 3, 4. More than one beams you can cast in the Hoyer's method. So this is called as the long line method also. Then in post tensioning system, wires are tension. Post tensioning system. बघा आता याच्यात काय. Wires are first tension followed by concreting. No. If the wires are first tension and followed by the concreting, then it is pre-tensioning system, not post. Tensioning of wires and concretes is done simultaneously. Simultaneously means एक साथ. Okay. So it is also no, because it is post tensioning. So the wires are tensioned against the hardened concrete. That is the correct answer. Once you pour the concrete, we let the concrete get hardened and then we pull the wires. Okay. Then the Prestressed system is based on the principle of, on which principle it is based? So direct bearing of concrete from bolt heads at the end of the wires. No, this is for Lee-McCall system. Looping of wires around concrete. No. Wedge action producing the frictional grip between the steel and concrete. Okay, so this is the correct answer for the Prestressed system. But next, high tensile bars treated at the ends are used in. High tensile bar threaded, sorry, not treated, threaded. So threaded at the ends. High tensile bars which are having thread at the ends, it is for Lee-McCall system. In Lee-McCall, we have seen that nut is there, washers are there. So to fix the bar is need to be threaded bar. Next is tendon splices are required in Hoyer's long line method, short span prestressing method, long span continuous member. So tendon splices are required for long span continuous members. This is the answer. Tendon splices are required for long span continuous members. Next is the prestressing steel has ultimate tensile strength nearly. Prestressing steel has ultimate tensile strength nearly twice that of HYSD bars, thrice that of mild steel reinforcement, 4 times that of HYSD bars. The answer is 4 times that of HYSD bars. So whatever the steel we use, apply the prestressing force and we prestress that steel member. So it is having 4 times more strength from HYSD bars. So remember this 4 times. Prestressing is economical for the member of longer span. I have already told you, for shorter span, for shorter scale, we cannot use the prestressing. It is uneconomical. So prestressing is economical for the members of long span. Okay. Then last one is the linear prestressing is adopted in कशामध्ये सर्क्युलर टँक्स मध्ये सर्क्युलर प्रिस्ट्रेसिंग असणार. Then pipes, it is also having circular prestressing. Beams, in beams we can adopt the linear prestressing. Okay, so answer is B. Okay, so now we will stop over here for today with this note. So our topic is also completed over here. So in the next unit we will see cable profiles. So we will came across the 3 concepts: stress concept, strain concept, load balancing concept. In the examination, the questions will be definitely asked based on this. Okay? So just wait. I will also take the screenshot of the attendance also. Okay, just 1 minute. What is the date today? November 12th. 12 November, BE A division. Attendance 95 to. Okay, just wait. Okay, now drop your roll number into the chat box. So we will end the lecture over here. Do it fast. Now I am going to end the link.